Good afternoon, everyone. Thanks for coming along. Just going to give it a couple of minutes for people to drift in. I think we're at about 40 or so participants at the moment, and we're expecting some more than that. So yeah, we'll just wait a couple of minutes and then we'll get going. Thanks for being on time. Okay, so it looks like we're about half full. I guess the rest of the class will come in as we go. So this week we're doing Unit 4, practical session 4, the second half of it. You'll have looked at the first half of this practical sheet in your classes earlier in the week. So I'll start sharing my screen now. Here we go. So the first part of this sheet. Sorry, just to remind you all before I get going. Everyone should stay muted, sort of by default, with your cameras off to save bandwidth. But if you have any questions that you'd like answered as we go, please chuck them in the chat. Manal will be checking the chat as we go, and I'll keep an eye on it, half an eye on it as well. Also, occasionally I'll be asking for people to shout out answers and stuff, so feel free to unmute yourself for that. But please be sure to remute yourself once you're done talking, and that'll keep things smooth running. So. The first part of this practical sheet 4, which you'll have been able to download from Canvas, was a continuation of using SymPy, symbolic Python, for solving various calculus problems and finding critical points in functions. That was something we touched on last week, and SymPy lets you set a variable as a symbol, and then lets you do solve various problems associated with that without necessarily evaluating it, as you might do if you were going to be trying to use some other method to do it. But obviously you can also evaluate these things. So that's symbolic pi. We're going to continue on. So task 3 was the last task that you'd have done or looked at in the previous session. So hopefully you've looked at all of these, this sheet by now. But we're going to start now looking at task 4. And task 4 is really kind of an application of what's been there in symbolic pi. Still using that to implement a very straightforward gradient ascent algorithm for finding a maximum in a function. So this asks you to grab this Python notebook from Canvas and open it up in your Jupyter notebook, and then run the program that's in there. So I've already done that. I'll zoom in a bit so that this is a bit easier to read. So this is this gradient ascent function here, and then here is how we'll invoke it, and this takes some user input in the form of the function and the variable that you're differentiating with respect to, and so on. So let's just have a look at this gradient ascent function that's been set up in here. This takes 3 arguments. X0, which we can see by looking further down the code, is going to be the starting value for our variable x. F1x, so this is the function that we're going to be evaluating, and then x is the symbol within that function that we're going to be working with. So this uses symbolic pi. The x that it takes in is a symbol, and we can see this gradient ascent algorithm is an iterative process, right? We get this is the bit where it does its stuff, and what we do is we insert the old value or our initial value of x, and then we evaluate our function here using that value of x. So this is the substitute x old for x in this function, and evaluate the function, multiply it by this by the step size epsilon, and then once we've done that once, we can then iterate it using this while loop. We've met while loops either in the last session or the one before, and so this is while the difference between your old value and the one you've just calculated is greater than some threshold, you carry on doing it, right? So we're just going to iterate round until these two values, until this converges, until we're making very small changes. And these are hard coded into the function. Now the function that we're taking, the function that we're taking in as an argument here is the derivative of the function that the user is going to input. So what we're looking at here, right, is working our way up the gradient that we get from that derivative until the gradient becomes close to 0, and then that's our maximum. Okay, so it's a pretty straightforward idea. So let's run this. So the first thing we want to do is put in the function, the function that we want in x, and that's given to us here. So it's x to the 5 minus 30 x cubed plus 50x. So x to the 5 minus 30 times x cubed plus 50 times x. And if we take a look back at the script, we're going to do this for 2 initial values.
Hello?
I'm going to cut and paste this, and then I'll be able to save myself typing it last time.
Hello?
Hello, yes? Okay, all right. So I'm going to just check that I've copied that out right. Could we mute that? Whoever that is. Okay, so I'm going to cut and paste that, and that way, when I have to do it again in a minute, I won't have to type it all out again. And the first time we're going to be doing it from -2. Okay. Oh, it's going to. Okay, we'll try that again because I put these in the wrong order. Put that in. We're doing it with respect to x, and we're starting at -2. Okay, and we get this out. Sorry, I'm just going to see if I can mute everyone for a second there. Okay, that's better. That's better. Right. So what we found was that the maximum of this function was found for an x of -4.2, and its maximum value is around 700. Okay, so now we'll try that again using a different starting point and see what we get. So I'm just going to pop that in there. We're doing this with respect to x, and now we're doing it from 0.5. Okay, and what we find is that we've gotten a different maximum, right? So does anyone want to, I think we can all probably think for a second and see why that might be. Does anyone want to either chuck in the chat or shout out why we've got two different maximums?
We've changed the domain of the function. Like before it was 2, I think, and now it's 0.5.
Right. Yes, we've changed the starting point, and perhaps what you're getting at is that what we've got here is a function which may not have a single maximum, right? So so this will just this algorithm, this way of doing it, will just ascend the gradient as it is where it is, and it won't be able to find other maxima if there are other maxima that are not local to where we are. We can have a look at this by just plotting the function using the skills we've learned so far in the course already. So I did this earlier, so I'm just going to cut and paste this from where I did it earlier rather than typing it all out to be quick. So we're just going to import NumPy and set up this function. Remember that -5 to 5 with 0.1 steps, that arange way of setting up an array that we did last time or the time before. And then we'll plot it, and we'll have a look at it. And this is, if you're going to work with a function, it's probably a good idea to plot it as a matter of course the moment you start working with it, so that you know what you're working with, and then this sort of thing won't be a surprise. But here we are. We started at -2 before, and we can see the -2 is going to climb this gradient and find this maximum here. And sure enough, that's what it did. We found the maximum at -4.17, and it was around 700. When we start at 0.5, it's climbing this gradient here up to a maximum around close to 1 here. And of course, it's completely missed this what we'll call a global maximum over here, right? So this is kind of the health warning with simple gradient ascent algorithms, and also a health warning that I think is worth bearing in mind, and hopefully you've all learned before already in things you've done before this, is that when you're given a function and you're going to start doing some operations on it, it's not a bad idea just to try plotting it out or scribbling it on a piece of paper so that you have a feel for what it is you're dealing with. And that way that you won't be surprised when an algorithm does something like this. Okay, that's task 4, which was using this this gradient ascent algorithm. So we've kind of changed pace now for the rest of the class, and we're looking at handling data sets, grabbing them from scikit-learn, where there's a library of data sets that we can use for exercises, and that you will be using more during this course. And then we're going to look at pandas, which is an extremely widely used package for handling data sets, and adds a lot of functionality that you don't get with just putting things in NumPy arrays. Although NumPy arrays are very powerful, and I probably admit that I use them more than I should. Pandas is a really excellent package, and should be the go-to for handling data sets, I think, for most of the stuff we'll be doing. So moving on then to task 5. And we're taken through this kind of blurb here, where we want to grab some data sets from the scikit-learn data sets. So we'll start by doing that. We'll import data sets from scikit-learn and load using the load method, load iris, which is a toy data set of data on flowers, for identifying flowers by their iris flowers, as the name suggests, from their petal properties. So from sklearn, you'll be pleased to know that I have got all of this updated in Python 3.8 now. And then we're going to load the iris data set, and we're just going to call it iris. Iris is so that's caught us up to here, and the first sort of subtask is to just explore the different methods that you get with a scikit-learn data set. So you can check the description. You can have a look at the data. You can have a look at the feature names. So the data is presented in terms of with a set of features, and then you have the targets and the target names. So as I risk of repeating myself, let's do the description first. And as I said, this is a data set about iris plants. We get 150 rows. These are divided amongst 3 different classes, which are different varieties of iris, and they each have each of these rows have numeric attributes, which we can look at. We'll look at the names, but they're basically describing the petals. So here's the target. We can look at the target names. So these are the 3 targets. These are the varieties of iris. And these are the features in the data set. So as we can see, these are the sepal length and widths and the petal lengths and widths of the flowers. Just check what else this one has to show. And we can look at the shapes of the different, let's look at the data shape. So this is how we just confirm how many. Okay, so as we said, we have 150 rows, and in each row we have these four features. Okay, so that's loading in a data set from scikit-learn. We can also do this using house price data, the Boston house price data. This data set is called Boston. To save confusion, I'll call it Boston. So this is task 5 itself. Now we've loaded Boston in. And all of the data sets in scikit-learn work in the same way. Boston has the same methods that we had for the Irish data set. This is a more complex data set though. This has 506 rows and 13 features on each row, and these are things like where are we? Let's get the feature names. These are things that you might expect to affect house prices. So we get the crime rate, the zoning, whether it's residential or business zoning. These are kind of metrics to do with the industrialization of the area, air pollution, nitrous oxide, and so on. And so then you can use these to then map onto the targets.
I have a question.
Yep.
So exactly, this is my question. Like, if we use the target underscore names function, is it a function or is it just a keyword to call the target names? Like, I'm asking in relation to the syntax.
Yeah, so it just grabs the names of the as I think as we say here of the classes in the target. So it doesn't, if there aren't any target names there in the data.
So should we use a bracket at the end? That's what I'm asking in relation to the syntax, because when I'm using the brackets, it's giving me a key error.
Yeah, no, I don't think we need to use the brackets at the end. No. Let's get one that just worked. Feature names. So no, that for these you don't add the brackets. I think what we're just seeing here is that
if you're using a different ID, like if you're using PyCharm or something like that, is the syntax going to remain the same?
Yes.
Or this is just for Jupyter Notebooks?
No, it's the same. It's the same syntax.
Thanks.
Yep. So this in this case, the Boston house prices don't have a set of target names in them. Let's just go back to the description and see what I think the prices are in there. Where are we? We have these different different features, and I guess there are no targets in this data set. I did think we had some prices in there as well, though. It's been a while since I played with the Boston data set. So we have target names, targets. Let's have a look at the feature. Let's have a look at the targets. There may just be no target name because I think there might just be one. It's just prices. But this is how you explore the data that you've imported. Oops. There we go. Yes, they're prices. So there's no name for it. And yeah, these prices I'm guessing are in tens of thousands of dollars, unless they're from like the 19th century. I'm pretty sure Boston house prices are. So this is probably $280,000 or $340,000. So then you can do all sorts of kind of interesting experiments to see how you might predict these house prices. And that's what that sort of toy data set's for playing around with. So that's how you play with grab and kind of explore a data set from scikit-learn. And then we're going to move on to pandas. So yeah, they don't always, features, I guess the point that I clumsily made here is that features don't always, the targets don't always have names. And you kind of have to explore a little bit to see what it is you're dealing with. Okay, so pandas. So we're going to look at the iris data set in pandas. And in this example, we're going to be grabbing the iris data from a URL instead of from scikit-learn. And that brings it in as a comma-separated variable file, which is kind of one of the most portable file formats, data formats that you can imagine, and that's why it's widely used. So we're going to grab from this URL. We're going to bring in this this iris data set, and we already know the names, the feature names, because we looked at them a minute ago. So I'm just going to just do it in here. So we want to import pandas. As PD. And we're going to check the version because so we're 1.2.1. I believe that was a step up here. And then we're going to import from this URL. I'm going to cut and paste it, obviously, because it's a bit of a pain. So that's the URL we're importing from. These are the names of the columns that we're going to be importing. Oops, so just confused myself. Yes, these are the names of the columns we're going to be importing. I can't cut and paste from there. There we go. The petal, various petal lengths and target, and then the target. And then we're going to use this URL. We're going to show the data are expected to be separated by commas, which stands to reason for a CSV file, no header, and the column names are going to be these. There we go. PD, I imported it as PD, didn't I? So there we go. So to look at the so we'll just check the shape. Excuse my on-the-fly typing. So we've got 768 rows and 5 columns. So this is a longer set than we had a look at from scikit-learn. And the next thing we're going to want to do is kind of see what pandas can do for us as we explore this. So the practical kind of quite reasonably suggests that we first of all have a look at the top and the bottom of the data. This is something that that really should be one of the first things you do when you get a new data set is just kind of have a look at it. If it's in a format like this where you can see how tidy it is, see if you've got lots of values missing, that sort of thing. It's very quick just to kind of have a quick delve in. So so we're going to do that now. And we're just going to iris underscore data. We do that with head. That gives us the first few rows. And similarly, iris data dot tail gives us the last few rows.
And can you zoom in your screen?
Yes, yes. Oops, there we go. That better? Okay. So, having done that, now we're just going to carry on kind of exploring these data. So we're going to take this bit here, iris data, sepal length, which is this column here, right? I need to put that in quotes, don't I? Yes. There we go. Okay. What is this doing for us then when we do this? When we do this with our data? You want to take a punt? I'll do them both so we can have a look at them side by side. Okay, well, these just grab the columns that we're interested in, right? Let's just have a look at them. Okay, so this is kind of, again, another way of looking at the data. So we don't have to we can use the column names instead of in NumPy you'd be using the column number. Okay, I'm just sorry. I've just got an eye on the chat. There seems to be some confusion about where. Let me just grab this. Oops, so have I used the wrong? Sorry, I've used the wrong URL. Here we go. This is the wrong URL. That's the confusion. I cut and pasted the wrong cell from the notebook that I'm working from. I grabbed diabetes data. Let's do that again. There we go. This should now match what you've all got. Sorry about that. This is the danger of doing things on the fly. What have I done now? I'll grab this one then. I'm ECS. There we go. Oop. There we go. Okay, so now why can I not find this? Find this ECS 4th edging. There we go. Right. Why can I not find this URL that's 4th ed? There we go. Right. Okay. So now this should match 150 by 5. This is looking more sensible, isn't it? Because we've got a target names instead of numbers. There we go. Okay. Sorry about that. Okay. So yes, so what these do is they let you grab, along with the row number, the value of a column, and you don't have to kind of list it as a NumPy array. There's a NumPy column. So the next thing to do is to see if we want to turn these into numeric values, and for that we can change the labels using the factorize function in Pandas. And what this does is take these string target names and turns them into a numeric class. So these are strings at the moment, and now we're going to turn them into into numeric classes. So if we just have a look at labels, it's going to be this array of zeros and ones. So Setosa is 0 and Virginica is 2. Does that make sense? Okay. So let's have a look back at the script. So the next thing we're going to do is look at taking a data set like we get from scikit-learn and turn it into a pandas data set. In pandas, we put these things, it's called a data frame. And so this first bit of code that we're looking at does that. So I'll put that in and I'll talk about what it's doing once I've got it into the notebook. So I don't think we've already imported NumPy in this session. Oh yeah, I did some plotting earlier, so I think NumPy is already in, and we've already got load iris. So let's just set load iris. Did I not do that a minute ago? No. Okay. From sklearn datasets. So we're going to import load iris. Then we're going to load iris. And then we're going to put it into a pandas data frame. So we're going to call this new data as it was in the script there. And this is the data frame. I'm just going to cut and paste what's in the script there into here. Okay. So what we have here is we're going to do we're going to have our data frame split into our data and our targets, right? And we're going to use this NumPy column function, right? And what this does is takes those that NumPy array that we get from scikit-learn datasets and pass it column-wise into this data item, and then we're going to take the target from iris, and it's going to be the target, and these are going to go into columns iris, and then we're also going to the columns are going to have the feature names and target, which are what come from that iris object. Okay, does that kind of make sense? That's what data frames. That's what we're putting into the data frame. Sure. Okay, we'll import NumPy. I imported NumPy in the other notebook, didn't I? That was what I did. Okay, there we go. So now we've got this this data here. And now we can kind of look at it using all the different kind of games we were doing before. So we can look at new data head, and that will give us a look at the top of it. And so what we can see is we've got our row numbers, we've got our feature names that we brought in, we've got targets. Now remember that when we got this from scikit-learn, the targets were numeric, right? They're already in they're already in this form. But if we have a look at this, these have a decimal point in them, and these are integers. This is kind of not ideal, right? What this is telling us just by looking at it is this is a float value, and we can do that as well. This is the other way to do this is just to look at what the data types are, and we use dtypes method on the new data, and we can see indeed that as we looked at when we just looked at the data visually, is that all of these have been brought into the data frame as floats, but we don't really want our targets to be floats, okay? Because these are a classifier, right? These are their class. You're not going to have a 1.5. I mean, you're not going to have a 2.3. They're all integer values. So it'd be a good idea to make this target an integer. Okay, so that's the next thing we're doing in this.
Ben, I have a question before you move forward. Could you explain what's happening where in the new data where you've created a data frame? Mm-hmm. Like what's the np.c?
Yes, go on.
Yeah, like could you explain the whole that row, please?
Yes. Yeah, sure. So np.c underscore, this is a NumPy function which will take an array, in this case data, which has four columns, right? And then passes it column-wise into the data frame that we're making, right? So instead of having to list, the other way we could do this, right, is if we did, let me just see. This may not. If I'm saying this may not actually work, but in a sense, what this is doing data 0, iris data 1. Let's just see if this. Even if this doesn't work, I hope this illustrates what this is doing, right? Right. So this is taking these four columns. The np.c underscore is taking these four columns and passing them as columns into this item. I ended up with a parentheses. There we go. No, you can't do it that way. Data 150 columns. I'm going to undo that. So this is passing. This, I guess, is. Okay. Yes. Sorry. So this is I've forgot these are both in the same square brackets. So this is again. This, as I said though, this is passing these things as columns, as NumPy columns, into this data array, rather than kind of they might otherwise get passed as lists and things.
Yeah. So basically, what's happening is that you're converting the NumPy rows into data frame columns. Is that what's happening?
Yeah, if you like. Yeah. So these are actually already in columns. These are the columns in the iris data already, but we're passing them. We're making them when we pass them across here. They're not going to get strung out into their list. We're going to pass them as columns, so each column will be a column in data. I'm trying to think of an analogous I guess a way to do this. I'm going to add another cell in here. And can I add another? I want to insert a cell so I can just show you an example. So if we just wanted to print out iris.data, comma, iris.target. What it's done here is put out these 4 data columns, right?
Yeah.
And then we've got the iris target, right?
Yeah.
But what we want to do is have them said as let's hope this does what I. Okay, what we want to do is send them as a continuous set of columns, if you see what I mean. Where are we? I need to put the square bracket here, don't I?
You're missing a bracket at the end.
At the end, yeah. Sorry, there we go. Right. Okay. Now you see the difference now.
Yeah.
So what this has now done is send them as columns. It's hard to articulate, but it's easy to show with an example. So that's what that NumPy column is doing. It's making sure they get presented as columns rather than as a concatenated list of columns. Follow me. And then with this line, we're just putting those columns. We're putting these names onto the columns, right? Okay. So as we had a look at these rows, the top few rows of this, and we can see that this looks like it's a float. And when we do the data types, we see that target is indeed a float. With that being a kind of a classification, it makes sense for it to be a different data type. So we want to change that. We're going to do that using as type, which is a pandas method that we can apply to this. And that's going to be as type. So we're going to pass. What we're doing is we're passing this from here back into itself, right? But as an integer instead of as a float. But we're going to keep it as a double precision integer at 64. There, and then we can check the data type again this way and see, sure enough, it's done what we hope it would do, and that's also going to change how this gets displayed when we have a look here, and we'll see that this is now reassuringly more like a classification. And that, if we look at the bottom, we see that indeed we see down to type 2. So does that kind of brings us to the end of this practical with the pandas will be back in the next session tagline. You'll be using pandas a lot, and it's good to get to grips with it. Does anyone have any questions about this stuff? We're a bit under time at the moment, so you've got time to talk about it, or maybe try some different things out with the pandas.
Yeah, I have a question regarding the data sets and what we are supposed to do with it. Like if you go on to Kaggle, you'll see the same data sets, the Iris data set and the Boston data sets for beginners. But what I don't understand is, like, what is the target? What do we need to achieve by using these data sets? What can we do with these?
So really, I mean, what they are is just kind of, as I say, kind of a toy data set to do analyses with. So you might use the Boston data set as a kind of for doing exercises using regression models. That's something you'll be doing in future classes, right? So you'll be trying to, you'll be picking, or maybe you'll use all the different features in the Boston data sets to see if you can model the house prices, right, using linear regression. And then in a practical application, that would allow you to write a website that would, or a service, or a, or as a real estate company or whatever, to price or come up with what the market price for different properties should be based on their features.
Are we going to perform like some of these things in the coming practicals after Easter?
Yes, you will be. So you will be doing, there's one practical, or several practicals actually, where you'll be looking at linear regression models using the Boston house price data set. Yeah. Similarly, you'll be looking at Gaussian. I think you use Gaussian mixture models on the classifying the flowers, classifying the iris data set. So you take those.
Are there any image related like practicals to where we process? We do processing or pre-processing on images or videos? Because from what I've seen, the main applications of PCA and all of these algorithms mostly are in image processing.
Yeah, no, you don't. I don't think you do any image, any kind of regression or machine learning stuff with image data sets in the practical classes. And there aren't any kind of facial recognition or any of that sort of stuff going on in these practical classes. No, I'm not sure if there's scope for that in your projects, but no, the practical classes that are coming will be kind of looking at the as I say, kind of modelling the Boston house price data set, working with this iris data set. I think there's another one using wine data sets. But they're, given the kind of the scope of these practical sessions, I think it makes sense that you're not getting onto anything more advanced at this point. And also in terms of computing resources that are required in order to do the analysis that you'd like to do. Those kind of things you're talking about might be a bit more in depth for project work.
Just the last question from my side. Thanks, Ben, for all the answers. The last question from my side is like from a professional point of view, there's a lot of talk about data analysts and data engineers. So what's the difference? If you could, give us a brief guide.
The difference between a data analyst and a data engineer. Not working in recruitment, I'm going to defer to that question. That's not my area of expertise. My gut would, if I had to speculate, the difference would be that an engineer works more on developing tools, which might be used by analysts in a more client-facing role. That would be my punt at what the differences are. In terms of someone that there's a difference between someone who builds and designs code that does it's one of the really important tools to be kind of very, very comfortable with. Okay, well, if there are no more questions.
Hello, Ben. Can you hear me?
Hello? Yes, I can. Yes.
Yes. So Ben, actually, we have a WhatsApp group, and there are around 260 students in that, and it's a humble request if you and all the faculty professors could upload the practical and tutorial videos. As we see, it is being recorded, and the thing is that the main reason we understand that these are not being recorded because professors are thinking that then students might not attend the classes when they are being conducted. But Professor, right now there are 2 weeks of vacation, and there is a fair chance that everybody we'll go back and we'll try and practice and see how it is. And this will help us get good marks. So any professor at the end of the day would want students to score good marks in the exam. So that is our primary motive, even for the professors, even for the students. So, so when this is our primary motive, that we all do well in the exam, then why not, this is just a suggestion. And this is what I've been seeing in the WhatsApp group, how students are, feeling terrible about practicals and tutorials. They're horrified at some point. So I just wanted, to bring that up. I'm not sure why everybody is not being so vocal about it and just speaking in the WhatsApp group. I don't know what's keeping them, from telling and being vocal about it. But I just wanted to bring this to your notice.
Okay. Yeah, that's noted. And we'll definitely raise it with the module leader, and see if see what comes from that conversation.
Yeah, because we really want to practice in the vacation, sir.
Yes.
This is the point when you will not get this time again.
Yes.
Just 2 weeks where we can, sit day and night and we can study. We are not going to get it again. We are again going to, rush into Unit 6 and then again into Unit 7, and then that is just going to be so on and on until the exam comes.
I see. So, yeah, I think you make a very good point. You make a very good point. So so leave that with us. As I say, it's above my pay grade. So I will we'll pass this on. And see what decision is arrived at by the rest of the more senior members of our module team. Is that okay?
Yes, we just hope that
it's the best I can do. I can't agree. Yeah. I can't. It's not in my power to agree to something. As I say, I take a point. I think you make it very well.
Yeah. So also, Ben, it is like, yes, we understand that the faculty wants us to practice, but at one point we are practicing, but at one point it is extremely time consuming, and there are in this semester there are 3 good subjects like neural network, machine learning, and data science all together at once. So there is a lot to cover, and we are kind of very scared at the moment. I don't know how to put this in a better way in front of you, but I am like, how do I do it?
Yeah.
And a lot of pressure. So
and I can understand having 2 weeks coming up without classes gives you a lot of freedom to kind of work on the things that you haven't had time for so far. That makes a lot of sense. That does make a lot of sense.
Yeah. So, thank you. It means a lot, Ben. Really means.
Okay. Well, we'll pass that on and see where we go. That's that. As I say, that's the best I can do at the moment. But I see there's a lot of I see there's a lot of people offering their support to what you said. So we will take this. This is very, very widely felt across the.
And this is just few people, Ben. Please, this is like, I would say 250 plus people agree to this on WhatsApp group. So this is not just 10, 20 people bringing it front.
Yeah.
So that's it.
Hey Ben. So when you say that it's above your pay grade, I just wanted to check: is this something that we can drop an email to one of the program leaders? Do you recommend us dropping an email, and we can just start dropping an individual email, and most probably the whole class should go through with it?
I would say that probably the best place is to start a discussion thread on Canvas. And everyone can comment on that, and the strength of feeling can be put on there. I don't think that if it's 260 people who all agree that having 260 emails arrive in someone's inbox is necessarily going to make their job easier. So I'd say the best place for this is the discussion, is to start a discussion thread on Canvas, and that can give you a channel for everyone who feels the same way to have their voice heard in a single place.
Perfect, Ben. I think that will do. Thanks a lot.
Yeah, great. Okay. Okay, so thank you for all getting involved as well. I do appreciate people interjecting and asking questions and pointing things out and all the rest of it. It's much nicer than talking out into the into the void, as sometimes happens when you're giving a Zoom class. So I hope you're all as vocal in your other practical sessions with those facilitators. I'll stop sharing now. And again, thank you all. It's really nice to hear your voices at the other end, and I know you're there and paying attention. So have a nice have a nice break. It sounds like you're all going to be working hard, but do also try and smell the flowers and the rest of it as spring starts to spring. And we'll see you all in a couple of weeks. Thanks a lot. Bye.